Hello everyone, welcome to SmartMe. Today we are going to be discussing effective performance evaluations for software engineers. This is a very important subject in engineering management. Performance evaluation is the process of measuring team members' output relative to the agreed upon objectives and key results over a period of time. Now, we work in organizations, right? And at the beginning of the business year or at the beginning of a period, each organization we have new objectives, right? And new goals that we want to achieve. We want to become profitable. We want to add 1 million new customers. We want to, and so on and so forth. Each of these objectives gets distilled down to the point where it can be assigned to every member of the team and of the organization as an OKR. Once an OKR has been assigned to everyone, right, then it becomes imperative that at the end of the period, we measure what is the output versus how it affects the expected, outcome. So at the beginning of the period, we said we are going to gain um, 1 million new customers. You as an engineer, you are supposed to deliver feature A, B, C, D to help the business achieve that objective. Did you really achieve that objective? Right. So let's look at how your contributions as a software engineer impact the business objectives. So let's say you work in a digital bank, right? In a digital banking company, startup, organization, and the organization has decided that for this year, the organization wants to have 1 million new customers, right? This is going to be in addition to the millions of customers that we have, right? And the reason why the business needs to do this is so that the business can become profitable, the business can increase investors' confidence, right? And the business can also deliver value for the shareholders. Now, the product team is going to now analyze this goal of having new 1 million customers, right? For us to get 1 million new customers, we need to automate our customer support process so that we can improve the customer experience, right? It's not going to be practical for us to hire 1 million new customer support representative. So for us to sustainably have 1 million new customers, we are going to introduce AI customer support agent, right? And number two, in addition to, in order for us to also improve the experience, we are going to improve the response time of our channels. We are going to improve the response time of our web channel, of our mobile app channel, and so on and so forth, right? So these then become the projects that is handed over to the engineering team to work on. Then the engineering team will take this project, refine it, right, further, and say, hey, for us to have an AI customer support agent, we need to integrate our system into OpenAI or into Gemini, and other AI platforms or LLMs out there, right? And furthermore, we will also need to vectorize our knowledge base, right? So that we can feed it into the AI model, and then so that the AI will become, or the customer support agent will become effective, right? That's one. Number two, for us to achieve the project breakdown of having to improve the response time, we need to optimize SQL queries, we need to introduce catch, we need to introduce this and that, right? So each of these refined projects then becomes a task that engineers then divide into sprints, and then after dividing them into sprints, now in each sprint, these task breakdowns then get assigned to each individual engineers. So if all goes well and each engineer delivered the task as at when due, then the business goal is achieved, right? There'll be profits, there'll be bonuses, investors are happy, everybody is happy, right? That is how important your contribution as a software engineer is. However, in the inverse, if one engineer decide, is not responsive, did not complete their task in time, or release a buggy app into production, and the team, instead of working on the next thing, they spend the whole sprint working on another app, or the engineering team or an engineer that is given the task of, estimating the work, refining the work, doing the technical specification, didn't do a good job. Therefore, we've underestimated the task grossly, and now it's going to take us 4 more months, to achieve this particular goal, and so on and so forth. If anything like that happens, if any engineer drop the ball, that is you and I, as we go to our desk every day, if we drop the ball, we didn't complete the task, what that means is that at the end of the period, the business is only going to have its 1 million new customers, and we will not be able to achieve the business goal. That means there will be no increase in profit. There will be no, if there is no increase in profit, the business can struggle to pay salaries and all of that, So that's how important your contribution is, as an engineer to a business achieving its objective. Now, software engineering performance evaluation, can said to be based on 4 major pillars. Number 1, we have technical contribution, we have team contribution, we have communication, and the last one is personal growth and development. These are the 4 pillars we are going to be looking at when it comes to evaluating the performance of a software engineer for a particular time period. Let's start with the first one, technical contribution. Technical contribution is referring to our primary job as software engineer, right? Which is we are meant to build the technologies, that help the businesses to achieve their OKRs, right? Therefore, it's imperative that we measure the technical contribution of each team member, right? And their impact. This is because the technical contribution of each team member is what we sum up, right, to the technical contribution of the team, of the engineering team, and which will also roll up to the business achieving our objectives. Now, when we are measuring technical contributions, what are some indicators or metrics that we can look at? So I have 5 listed here. Number 1, quality and quantity of merge requests authored. Number 2, quality and quantity of merge requests reviewed, right? And then number 3, quality of projects completed, speaking about technical ownership. Number 4, we have quality of technical specifications authored. Number 5, we have team's technical challenges resolved. This is also speaking to technical ownership. We are going to look at each of them in a detail. Now, looking at quality and quantity of merge request authored as it pertains to the technical contributions of a software engineer, right? This means we are looking at how many code changes did an engineer contribute to the code base, right? Let's not forget how our contributions as software engineer really matters, right? You contribute code changes, you make code changes. These code changes helps to achieve some project. This project helps the business to achieve our goals, right? So it is very important then that we review not just the quality, but also the quantity, right? So if you are evaluating an engineer, you need to look at how many code changes did this guy make, right? And what is the quality of these code changes? So is it that the engineer is the one that is contributing code, that their pull request becomes a Twitter thread or an X thread, right? Where everybody is commenting, you have to change this, you have to change that, because the ticket says do A, the submitted code change is doing B or is doing C or D, So those are the things that you look at when you are evaluating the performance of a software engineer. Now, you also need to look at quantity. For example, for a senior engineer, for a senior software engineer, it is expected that because of their experience, because of their technical know-how, right, they are able to contribute more code, right? They are able to take on more tasks, and because they take on more tasks, they are able to, have more number of changes, right? So remember here, we are not just looking at the sheer number of code changes, right? No, we are not looking at that. We are looking at the quality of the code changes. Is the code change, is it doing what is expected to do, right? So the code changes that is being authored, is it up to the standard that is expected, right? So those are the things, that's one metric that we can look at when it comes to evaluating the technical contributions of a software engineer. The second metrics that we can look at is the quality and quantity of merge requests reviewed, right? So what does this mean? This means that because as engineers, we work in a team, right? And it is expected that while engineer A is making the code change, submitting the code change, the other member of the team are expected to review and ascertain that the submitted code change meets the expected standards, satisfies the project requirement that is documented in the task originally, and is achieving the set goal, right? So this is going to help us as an engineering team to deliver more quality product, right? So what this means is if the person authoring the code forgets or accidentally uh, put in some bugs or overlook some things, right? It means that during code review, those things can be arrested in time and they can be solved right before they make it to production, where they become a production incident and they drag the team backwards, right? So that's why it's important that we evaluate every software engineer in the team, the quality and quantity of feedback that they are giving to other people's code, right? Because imagine a team where no one is giving quality feedback. What that means is that code review becomes an action of ticking the box, right? Nobody's paying attention or even looking at it thoroughly. What that means is that buggy code will get shipped to production. If buggy code gets shipped to production, we will have frequent production incidents. We will have frequent downtimes. Our customers will not be happy. That's number one. We are going to lose revenue because during the downtime, there are some transactions or revenue that the business is supposed to be making. The business will not be making that, right? And furthermore, the business will not be meeting its objective of gaining new customers, right? So you see how everything sort of feed back into each other. So that's why it's very important that when you're evaluating the performance of an engineer, you don't just look at what they have, the code changes they have authored, but we also look at the quality and quantity of their feedback. So we want to reward someone that is consistently giving feedback, giving quality feedback to other people's code. Those ones are the gatekeepers. They are the ones that are ensuring that our production is safe from buggy codes, right? The third one that we want to look at is the quality of projects completed. So I understand that there might be some team where, for example, an outsourcing company where we work project by project, and maybe in such companies, the project is assigned to a single engineer, right? So in such scenario, such company can have the goal of say, hey, we want to complete 10 projects in the first half of the year, right? So why it's important to evaluate this metric is if the engineer do their job well, they completed the project properly, the project is not buggy, it's scalable, it's working as expected, right? It's reliable, it's always online and behave properly. That means the business will be able to achieve its objective. However, on the other hand, if the engineer that is assigned to a particular project do a shabby work, there is production incident or the customer is not happy, that means that instead of being able to do 10 projects in the first half, we'll probably be able to do 5 or 4, definitely lesser than 10, because now you have to fix whatever mistake that has been done, right, on this project by the engineer. And worst case, you might have to bring another engineer now to leave whatever they are doing to come and correct what this particular engineer is doing. So that's why it's very important when you're evaluating the performance of a software engineer, you look at the quality of the project that they are completing, right? Especially in environments where each engineer is assigned to a particular project to complete it end to end, right? So this is why I tag this one technical ownership. Quickly, let's go to the fourth one. So for the fourth one, we are going to look at quality of technical specifications. There are some companies where as soon as the product team comes up with a new project that we need to do, the engineering team will assign a technical owner. Then it becomes the job of this technical owner to do a deep dive into this product requirement and itemize what needs to be done, what are the applications we need to change, what are the new applications we need to create, uh, what's going to be the right SQL query to use, the right set of technologies and tools to use to be able to achieve this project, right? All of that is documented, right? And then the document is called technical specification, right? So why is it important that we evaluate the performance of a software engineer based on this, right? So imagine a pipeline, right? The product team has come up with a product requirement. An engineer is supposed to do a tech spec, but instead of doing the quality one, they, it was shabbily done, right? And because of that, during implementation, the engineering team had to have a stop, and start scenario because there are so many unknowns that ought to have been answered in the tech spec that is not answered, right? Or even worst case scenario, there is a scope that is supposed to be covered, but because the tech spec did not cover it, now the engineering team is realizing it during QA or during acceptance testing and so on and so forth. And now the scope of the length or the duration of the project will change, right? So imagine at the beginning, the product requirement was handed over to the engineering team. The engineering team appointed a technical owner. The technical owner says, hey, I'm done with this tech. And based on this tech spec, the manager says this task is going to take 2 sprints. But because the tech spec is not done thoroughly, right? Now the project is taking 4 sprints. Now the engineering manager will have to communicate to the product person. The product person will have to communicate to the executives. The executives will have to communicate to the business owner and to customers. And sometimes customers are just not that patient. They will not wait for you, right? So there are alternatives. So that's why it's very important that we evaluate in environments where we are writing technical specifications, we evaluate what is the quality of technical specifications being written by an engineer, right? So that we can promote this kind of trait, and then we can discourage or work on engineers that are scoring low on this particular metrics, right? The last one here I have is team's technical challenges, right? For an engineering team, there are typically common challenges. Let's say, for example, we have a pipeline that is taking 30 minutes. And because the pipeline is taking 30 minutes, right, that means our project is taking maybe 2-3 days longer to complete, right? Because you have to deploy, and because before you deploy, we take another 30 minutes, and you want to see the outcome of the deployment, you have to test before you begin to pick up the other tasks that are needed for the business to achieve our objective, right? So if you have an engineer that just say, hey, this pipeline, I'm going to optimize it, and indeed, the pipeline is optimized, instead of taking 30 minutes, it now takes 15 minutes, right? So that means that engineer has solved that technical challenge that is facing the team, right? Another example might be that you have a particular nagging monitoring alert, right? It always happens every now and then, and every time it happens, it brings the whole system down. Yes, we have a solution, but this thing is not, the solution is not permanent, it's a temporary fix. So, but an engineer take the initiative, and then they decide to fix the problem once and for all, right? So these are the metrics that we want to look at, right? When we are evaluating the performance of an engineer. So for example, if you have an engineer that is taking ownership, solving team's technical challenge, churning out quality code, giving quality feedback, writing quality technical specifications, they are definitely going to be rated high, right? And once they are rated high, you are sure that the people in your team that your performance evaluation is saying are high performers, they are indeed high performers, right? So that's why it's very important that we look at these key metrics. There are other key metrics that we can use across board, right? So last thing that I would like us to speak about when it comes to performance evaluation is we need to make it more scientific, right? Rather than being an opinion of a manager of a tech lead. How do we do that? We look at sources of truth. For example, we can look at the remote code repository, be it GitHub, be it GitLab, and look at the merge request. From there, we can see the quality of the merge request that an engineer is, authoring, or the quality of their feedback to other people's merge requests, right? So because you are seeing it right there and there, it's not doctored, it's right there, is the contribution, that makes whatever rating you give that particular engineer based on that, to be much, much substantial, right? And evidence-based, right? So for example, for this source code contribution analysis, for example, we are not looking at number of lines of code, right? No, we are not doing that. You can actually look at their contribution and the quality of their contribution. You're looking at their hair marks, does it have comments and all of that. You can use advanced tools like Linear B, which will even give you the quality of their comment, right? Of each engineer as related to other people's code base, and even the quality of comment or the number of comments on each of an engineer's merge request. So these are the tools. This is the place where you can get that. So you can also consult Slack or team chat, where what you are looking for here is that you are looking for, evidences of an engineer responding to a particular production incident, responding to taking ownership, telling people I have solved this, and those becomes hard evidence to support the rating of an engineer, especially when it comes to their technical contribution. Of course, you can look at ClickUp, Jira, or other product management tool. From here, we can see how many number of tickets that they complete, what's the nature of those tickets, and so on and so forth, right? You can also look at your document repository like Drive, Notion, OneDrive, there you can see the tech spec that they've written in the past. If there's any guides, any wrong books that they've written, you can see it, and then it becomes a support. So if you say this person writes good tech spec, and then you can just link to say, okay, these are 2, 3, 4, 5 tech spec that they've written in the past, and based on this, I can say, and I look at the quality of the tech spec, and I'm able to say they are the person, they write good tech spec. Incident response log is also another part that you can look at, right? You can look at how they contribute or how they respond to incidents and so on and so forth, right? I'm going to pause here. Please watch out for another uh, video where I'm going to talk about the other 3 pillars, which is the team contribution, communication, and personal development and growth, right? So each of these pillars is important when you are evaluating the performance of a software engineer. Thank you very much for joining today and for listening. I'm just trying to build this channel, so please like, subscribe, refer the channel to your friends, share this video in your circles. I appreciate it a lot. Please watch out for the next series, and see you next time. Bye.